Well, good evening, friends. Hello, good evening.
Good evening, sir. Good evening, sir. Good evening, sir.
Right? Right. So now you see, we will once again do it today. So the mistake here was that that we have to consider about the axis. See, I deliberately put it like that to all of you, so that you all should appreciate. See, when we calculate the angular momentum, angular momentum we calculate it with respect to a point. Okay, but when we are calculating the moment of inertia, because the purpose of moment of inertia is to find out the inertia of rotation, and rotation always means with respect to an axis. Okay, so now also the same thing here, the same patch, same patch here with respect to this. This is r, and this becomes r sin theta. Okay, so now our dm. Here dm will be equal to m divided by 4 pi r square, okay, into this area. This area we took it as r d theta as it is, correct? Okay, r d theta as it is, correct? And then we got that patch area as r sin theta into d phi, okay? And dm, this is dm is correct. I hope all of you got this.
Yes, sir.
Yes, now, as far as the integration is concerned, integration dm into r sin theta whole square. This is what we have to do. Hello.
Yes, sir.
This man, this one with respect to this axis. This is what we have considered. Everybody understood?
Yes, sir. Yes, sir.
See, I can teach for hours together, but if I scream like this, my energy will be gone. So you have to respond. Yes, no, please repeat, whatever it is. Or you say, please wait. That's also accepted. Did you all get it?
Yes, sir.
Thank you. Okay, so here we go, and we fix the limits of integration for this and do it like this. So here dm value, we'll put it as it is, m by 4 pi r square as it is. Okay, anyways, I can simplify it here only. So this r and this r and this r gets knocked off. Okay, there itself it gets knocked off, and m by 4 pi is the constant, so I will pull it out. I'll pull out m by 4 pi. And then the rest of the terms is inside this. The rest of the terms is inside this, because we have got d theta and d phi. I am going for two integrations here. While theta will go from 0 to pi, and phi will go from 0 to 2 pi, right? And now we are going to write there. So whatever terms we have got there, we have got sin theta, and then we have got d theta, and then we have got d phi, and then we multiply it by r, okay, r square sin square theta. Okay, so that will leave us with m by 4 pi as it is, and we will pull this out d phi, and we'll integrate it from 0 to pi. Okay, and again this r square is constant here. I'll pull out the r square here, and I will have to integrate sin cube theta d. Got it, friends?
Yes, sir.
Now somebody can tell me how to integrate sin cube theta.
We can split it as 3 sin.
Yes,
T equals sin theta, sir. We use substitution, integration by substitution.
You take t is equal to sin theta and do it. But
We can directly use even formula, sir.
Have you done this before?
Integration by substitution.
You have done integration by substitution of sin cube theta? I don't think so. Anyway, I'll just do it because let's be pretty quick here now. Okay? Can't spend. Can't do it. Wait a minute. What we have?
We can use the formula for sin theta minus sin cube theta is equal to.
Okay, so if you know how to do it, you do it. Okay? I will also do it my way, you do it your way. Your school of thought, my school of thought. Okay? Let's do it. If you are so confident of doing it, please do it. Please go ahead. I will also do my way. Right? Okay. So I am going to do it like this. So sine cube theta, I will write it as sine square theta into sine theta, and this one I will write it as 1 minus cos square theta into sine cube theta d theta. Okay, d theta. So this one I will write it as 1 minus square theta sine theta d theta, and now I'll say cos theta is equal to u. Therefore, if I differentiate this, I get it minus sine theta, okay, into d theta by du is equal to 1, and therefore I will get sine theta d theta is equal to d minus d. Okay, so I will go about substituting this here. So I will get here in this 1 sine cube theta, I can write it as 1 minus u square, and sine theta d theta I will write it as d. Okay, so my integration now will be integration of 1 minus u square, okay, into du. 1 minus u square into du, and this one, if I integrate it, I will get here u minus 1 by 3 u cube. Okay, this is what I am going to end up with. Okay, and now if I substitute here, so integration of 1 minus u du, integration of this. See, now if you have learned integration by substitution, I said u is equal to cos theta. Correct? Hello? And the limits for cos theta, we took it as what? The limits of theta, we took it as what? Theta is 0 to pi. Okay, that means cos theta value will go from 1 to minus 1. The value of cos theta for 0 is 1, and the value of cos theta for pi is minus 1. Am I right?
Yes, sir. Yes, sir.
Correct? So therefore, if you put cos 0, I should get u is equal to 1, and if I put cos pi, I should get it as minus 1. Therefore, this integration, I have to integrate it from what? From what to what I should integrate? From 1 to minus 1. I hope you know this now?
No, sir. New things.
New thing. Okay. Well, you integrate this. If you integrate this, what do you get here? So you will get here integration of this, you will get it as what? Integration of 1 minus u square du in the limits.
U minus u cube by 3.
U minus u cube by 3 and u minus 1 by 3 u cube. Correct? Now put the limits as 1 to minus 1. So what will you get here? So minus 1 minus 1 by 3 u cube. U cube will again give you minus 1. Isn't it?
Yes,
So this will become plus. So minus of. Now I have to put 1 here. 1 is, I get it as 1 minus 1 by 3.
1 minus
1 by 3.
Yes, sir.
Correct? So this is minus 1 here, and this will also become minus 1. So what will be this sum of this? So I will get it as minus 2 into minus plus
2 by 3.
2 by 3.
So that minus sign I missed out.
Again I missed out, I know. Again I missed out. I missed it out, I missed it out. So
Then
it will be
minus
ulta.
right.
Then it will be ulta.
Yes, sir.
Isn't
Sir,
it?
which
2
minus?
minus 2 by 3.
Isn't it? So this whole thing will be, see, there is minus cos theta, right?
Sir, sin theta d theta is minus du, sir. So it should be u square minus 1 d1 integration.
Other, that's
So that thing one is correct. So last one.
so last only I should change. So here
Yes, sir. So it will be 2 minus 2 by 3, sir. Last.
2 minus 2 by 3.
Two
Correct?
by-
No,
yes.
that's all it will change. Got it?
Yes, sir.
Huh?
Yes, sir.
Got it, friends?
And integration d will get 2 pi.
Integration to 5 will get 2 pi. Isn't it? So
Yes, sir.
m r square by 4 pi.
4 by 3.
M r square by
2 minus 2.
Sir, 2 minus 2 by 3 is 4 by 3.
1 by 3.
4 by 3.
okay, sorry, sir. So m r square, I am doing it in hurry. M r square by 4 pi integration d phi. integration d phi is 2 phi, isn't it? No, because this is a constant.
Yes.
So now this integration we got 4 by 3 into what? 4 by 3 into
D phi.
d phi. Okay, 4 by 3 d phi into d phi. Correct. So again you pull 4 by 3 here. So if you pull 4 by 3 here, you will get here m r square. Okay, by 4 will cancel. So 3 phi. And integration d phi from 0 to 2 pi will give you 2 pi. So 5 pi will cancel. So you will get here 2 by 3 m r square.
Yes.
This is
Yes,
next.
sir.
Yes, sir.
I hope all of you got this. Hello.
Yes, sir. Yes, sir. Yes,
Fine.
sir.
Sorry, I didn't want to spend much time integrating and all. Right? You will learn this. It's not a big thing. But I suppose I did it simply for you in a simple way to do it. I did it. So we got the answer 2 by 3 m r square. Anybody knows that for a hollow sphere it is 2 by 3 r square?
Yes, sir.
Sure?
Yes, sir. Correct, sir.
Okay, fine. So I suppose we did it. We found out what are the mistakes there. Remember, angular momentum will be up to a point, but when you are talking about moment of inertia, we have to make sense out of it. The sense is moment of inertia is the inertia for rotation, and it is always calculated about the axis of rotation. Okay, and the last class, we were attempting to do it about a point, and therefore we goofed up. And nothing wrong. We should learn from our mistakes. Okay, we should not shy away from our mistakes or start coming. Whenever we end up with something wrong, we have to go back to the basics and see like which concept did we apply wrong. Okay, and that's how the conceptual clarity will keep on increasing. All right, folks. So that's it. All right. So, well, he also got it as 2 by 3 m r square. But only thing is, instead of taking this theta, they have taken this theta, and so they have ended up with cos theta. Instead of sin cube theta, they have ended up with cos theta, and they said r is equal to r cos theta, and that is something. Anyways, this is another way of doing. That is another way of doing it. Right? Got it?
Got it, sir.
Yes.
Done. Huh? Right. I have not introduced the spherical coordinate system here, but I have already used spherical coordinate system here. Okay, a part of it. But when time arises, I will explain that to you. Okay, this is another way of coordinate system by which we can handle this. All right, there we go.